Okay, so we have 24 feet of fence. What's the maximum area? I'm going to go ahead and make a chart. I think it's a smart thing to do is to try to go about this in a systematic way. So width and length and area, right? So if I had a width, let's start with I don't know, 1 foot width. So what would the length have to be in order to have 24 feet of fencing? So it'd be 1 and 1 would be the width, and then I would need 22 to make up the rest, right? So that'd be 11 and 11. So the area would be 11. 1 times 11. Alright, so I could probably do better than that. Let's try 4 feet. So I'd have 4 and 4, that's 8. So I have left over 16, which would be 8 and 8. So the area of this would be 4 times 8, which would be 32. So this is definitely bigger, right? So my area, I don't think it's going to be thinner than it is long, right? So let's try going a little higher. How about 5? So if I have 5 and 5, that's 10, and I need 14 more, so that would be 7 and 7. Okay, so that would be 5 times 7 is 35, so even bigger still, right? What about, let's try 6, right? 6 and 6 and 6 and 6, that makes 24, right? So 6 times 6 is 36, so even bigger. Now we go, if we go past that, so let's try 6.5, right? 6.5 would be, let's see, 6.5 and 6.5 would be 13. So I need another 11 to go. So that would be 5.5 and 5.5. So what's 6.5 times 5.5? I'll grab my calculator just to make it easier. Equals 35.75. So it got smaller, right? So my guess is that it would be 6 by 6, that it would be a perfect square to give us the most amount of area. And if I go further, if we go 7 and 5, that's just back to 35, right? So it seems to me that the maximum amount of area fits right in with W squared. And this is a kind of quadratic equation that we're setting up. So W squared equals the area is a quadratic equation. And we're going to be talking about how to solve quadratic equations like that.